A new carbon economy. One disturbing fact that we have to deal with is that a lot of carbon that will have a warming effect on the planet over the next 100 years is already in the atmosphere. So, even if we get to carbon neutral targets in the next few decades, we will still have to remediate the atmosphere for possibly hundreds of years by drawing carbon dioxide out of it. The project revolves around the climate emergency that we face globally, where there are articles, discussions, talks on the vulnerability of the air we breathe. We're specifically focusing on carbon. On a global level, the presence of carbon in the atmosphere catalyzes climate change, and the construction industry contributes to 40% of the emissions. Reducing the carbon footprint of a construction could entail more sustainable construction and a more public conversation about this material. Governor's Island is a 172-acre island in New York Harbor. With no living communities, a beacon for climate change, the island allows us to introduce carbon sequestration methods. Here is a timeline that shows the specific issue. With time, we have been digging out terrestrial carbon and using it for construction and mobility. The atmosphere is not a great carbon retainer, and when buildings are demolished, carbon gushes into the atmosphere in an enormous amount. This results in an increase in the atmospheric carbon levels. Carbon is an important component of our atmosphere as it maintains a livable temperature, and an increase in carbon would mean an increase in global temperature. As a result, we explore a new architectural language that is both functional and can be used as a building aesthetic to align with the objective. The initial visualization of the project outcome is in three steps. One, where we enable the adaptive reuse of the barracks. Secondly, a structure designed to accommodate a technology that extracts atmospheric carbon. Third, introduction of a trajectory as an immersive experience. The These are few images of the material exploration that we did initially. The territory map shows the planning scheme of the project outcome, including the barracks, the direct air capture technology, and the trajectory. The following section shows a study of the atmospheric carbon levels over the last few years. The use of water from the water table to filter carbon from the atmosphere. This section shows the level of the existing ground and the new ground along with a precedent of the marble quarry to give an idea about the aesthetic. The concept section shows the parts of the carbon landscape, organic carbon form and the linear block carbon form. The robotic model is derived from the physical model and it comprises of the carbon filter technology. Climeworks technology captures the air which is passed through a selective filter material. Once the filter material is full of CO2, the collector closes and it's heated to 100 degrees Celsius, and the captured carbon dioxide is mixed with water and pumped into the ground. Our proposal is to use this filtered carbon dioxide with fresh concrete to reduce the carbon footprint without compromising performance. Once injected, the carbon dioxide undergoes a mineralization process and becomes permanently embedded. This mixture will then be used to make concrete blocks that fabricate the emerging landscape. The calculation indicates the amount of filtration by each turbine and the quantity that will be used to make sustainable concrete blocks. Annually, the project generates carbon equivalent to build 5,300 sustainable concrete blocks. These diagrams show the wind direction around the Hudson Bay that help us better understand the placement and the orientation of the building on Governor's Island. Governor's Island already has proposals to build on the Eastern Development Zone and the Southern Development Zone. The axonometric view indicates the division of the site into two phases. As of now, we are developing phase 1. The idea is to redirect the coastal road on the edge of the Eastern Development Zone around the site and convert the existing road into a green shoreline. The structure design comprises the turbines that absorb the polluted air flowing from Manhattan and filter it. A video representing the evolution of the landscape with time. During the course of the trajectory, the blocks are placed around the trees, which in turn act as interactive spaces for the visitors. These spaces are green patches to break away from the monotony of the carbon landscape. One of the views of the top from one of the topmost concrete blocks. Zooming in, the built mass holds the turbines and the other sequestration units on the upper level, and there is a trajectory that passes through the lower level. It is a choreographed experience of a distinct kind where the audience witnesses the crumbled black dark pockets that showcase the unwelcoming scenario on the planet if the atmospheric carbon keeps increasing. The design and research till this point testify that sequestration can speed up and we can build a brighter future for ourselves. But so far, carbon sequestration is done at industrial scales. To dig deep into the possibilities of carbon infused materials and its capabilities, we started exploring the aesthetics of carbon on a landscape scale. And then, in order to understand the various technologies of direct air capture and the difficulties of how they go together, we have explored it on a prototype scale and a cultural scale.
Carbon Nivas houses the idea of sequestering carbon at a human level and driving the climate literacy program into the next phase. It houses the possibility of capturing the carbon in the simplest way, making it possible to include it into the building code. On the right, we see a diagram which is more or less explaining the central core flowing into different scales, including landscape, architecture, and the prototype level, binding the whole project together. The concept revolves around proposing a central core that would flow through spaces and have an interactive cap around it for human engagement. The tectonics of the junction between organic and geometric forms became the driving force of both the architecture level and the prototype level proposal. Here is a system diagram that shows how the Arduino controls the engagement with humans as the prototype senses movement. This is the system and this is the core and cap. The mixture of potassium hydroxide and water is in the central core, and as the bubbling starts, the air molecules are pushed into the core where CO2 bonds with KOH. This binding isolates the carbon within the core, reducing the ppm levels of the CO2 within the core. The more people interact, the more carbon is isolated. These images give an idea of how interaction induces carbon sequestration, an experiential aspect of bubbling water, sound, and visual effect. Our ambition is to use architecture as an agency to make people conscious about the presence of carbon and its possibilities to create a carbon economy. The idea is to bring people closer to the direct air capture technologies. The following sketches show the initial development of the design that incorporated different experiences for the visitor through a natural exhibit and artificial exhibits that sequester carbon. The updated master axonometric realigns the architecture intervention on the Eastern Development Zone. The idea remains to adapt the barracks as a part of the project and place the building above it. The barracks become processing units and spillover space for the carbon plaza. To break down and understand the building, the various design components show the development of the structure from circulation to green spaces. The building has one lift core, two staircase cores, and a living ramp that are subject to vertical circulation. We get into the details of the ramp ahead in the presentation. The diagram on the right establishes relationship between old and new. Articulation in the structure, spatial organization shows how the museum and the exhibit and the workshop spaces are placed. This is how old and new coexist, and there is an overall diagram. The site plan advocates for the monolithic aesthetic that the architecture adapts and as it sits on the blocky and pixelated landscape built out of carbon concrete blocks. This is what we call the carbon plaza. It is extremely important to dive into the materiality and the potential that carbon sequestration has to offer. The take of monolithic aesthetic offers us to carve and build everything out of carbon blocks that come out of an altered form of carbon. Two sizes of blocks come together and form an interactive space. As a part of the process, steps are carved or made out of carbon concrete. The design of blocks is further modified to make planters of different sizes to hold trees and bushes. This is to show how we imagine the application of these blocks on the project alongside it being used as a construction material. There is a conscious addition and subtraction of blocks to create playful spaces. The section cuts show the spaces in the museum from exhibition to workshop areas and museum facilities and the carbon plaza itself. The other side of the build provides a peep into the core, Exhibit 1 and Exhibit 3. To see physically, it would enable us to see the textures and how its materiality connects back to the model we casted in the previous semester. While we talk about different exhibits, one of them is live direct air capture through the turbines that work based on the Climework technology. Exhibit 2, a collective that makes a direct connection with the exterior, the technology that we depend on to alter the carbon form for different applications. While we conduct the project to embrace carbon and existing fabric, we treat the structure as a living laboratory and torchbearer for climate and social literacy. The ramp also takes the audience into the next level, but offers a viewing deck to appreciate the carbon landscape and architecture envelope. While people walk, stand, and or adore the building at different points and different times or on the ramp, the ultrasonic distance sensors installed on the rail sense movement and induce carbon sequestration in the core that stands tall. The visual effect and the bubbling sound is a provocative way to encourage engagement through the pathway. Thank you.